In this video, we're going to talk about the chain rule, which actually adds a lot of options for us in terms of taking the derivative. In the last lesson, you were asked on one of your try this problems to find the derivative of f of x equals sine squared of x. And you were given the hint that you needed to use the product rule. So if you wrote this as sine of x times sine of x, you could use the product rule and find the derivative. I'd like to talk about how we can use the chain rule for the same problem. But first, I want you to recognize that this function can be rewritten as sine of x quantity squared. And make sure that you have the parentheses around sine of x, because this sine squared of x means sine of x quantity squared. So the chain rule basically tells us if we have the composition of two functions, so if h of x is the composition of f of x and g of x, and I like this notation, although you should be familiar with both of them from pre-calculus, then what we can do to take the derivative of h of x, so h prime of x is equal to f prime of g of x. So you leave the inside alone, you take the derivative of the outside function, and then you multiply it times the derivative of g of x, or multiply times the derivative of the inside function. And let's look at this example so that we can better understand it. So I'm going to write f of x as the composition of two functions. And so I'm going to call the inside function, let's go ahead and call that g of x. And g of x would be sine of x. And then h of x is the outside function. And the outside function here is x squared. So if I wrote h of g of x, so if my f of x is equal to h of g of x, that means take g of x, which is sine of x, and plug it into wherever there's an x here, into h of x. So then that is equal to sine of x quantity squared, right? We're plugging sine of x in for x here. So it's going into this x value, and we're squaring it. So notice that these two things are the same. This is the same as this, right? So I've written f of x as the composition of h of x and g of x. Now, the derivative, the chain rule for derivatives tells us we're going to take the derivative of the outside. So take the derivative of the outside function, and the outside function is my h of x, which is x squared. So I take the derivative, I bring that 2 down front, just using my power rule, right? And we leave this inside function alone. And now this is to the 2 minus 1 power. And then you need to multiply times the derivative of the inside function, and the inside function is our sine of x. So the derivative of sine of x is cosine of x. So our answer is just 2 sine of x cosine of x. And if you were to do this, go back and look at your work from doing this with the product rule, you'll see that you get the same answer. So let's review really quickly. If you have the composition of two functions, when you take the derivative, you take the derivative of the outside function, leaving the inside alone, and then you multiply times the derivative of the inside function. Let's look at some more examples. All right, let's look at another example. Let's suppose we have a function h of x, which is equal to the sine of 7x plus 2. What is our outside function here? So if we had, and you don't have to do this with each problem, I'm just trying to help you identify the outside function and the inside function. So our outside function, if I called that f of x, would be called sine of x, right? And our inside function is g of x equals 7x plus 2. So I could rewrite h of x as f of g of x, couldn't I? That means I'm taking g of x and I'm plugging it in wherever there's an x into f of x. All right, and you can see that that's identical to what we have here. So if I want to take the derivative of h of x, I take the derivative of the outside function, and the derivative of sine is cosine, and I leave the inside alone for now. And then I multiply it times the derivative of the inside. And the derivative of the inside is just the derivative of 7x plus 2, which is just 7. And note that these two are not multiplied together. This 7 is not multiplied by this. The 7 needs to go out front because it's multiplied by the whole thing. All right, so that's h prime of x. Now, the toughest part of doing these problems is determining what the outside function is and what the inside function is. I want to look at one last simple example. F of x equals x squared plus 3x minus 5 to the third power. And I want you to pause the video and try to take the derivative of this. I want you to find f prime of x, and then start the video back up and see if you get the same answer that I get. So I'm going to let g of x equal x squared plus 3x minus 5, and h of x be x cubed. So I could rewrite f of x as h of g of x. Correct? That would be x squared plus 3x minus 5 to the third power. And when I take the derivative of f of x, that's going to be the same as taking the derivative of h of g of x, which is going to be h prime of g of x times g prime of x. Okay, and so that is equal to h prime of g of x is just 3 times x squared plus 3x minus 5 to the second power, and then we multiply it by g prime of x, which is the derivative of this, so it's times 2x plus 3. Again, it's just taking the derivative of the outside function and leaving the inside alone, and then multiplying by the derivative of the inside function. Hopefully you got the same answer.